We've written an assignment operator and a copy constructor, and so far it really hasn't provided any more value than the copy constructor and the assignment operator that are provided by C++. The reason that we need to be able to write our own copy constructors comes into play when we have pointers that are private data members of our classes. So let's take this example here. We have some class, and the private data member is actually a pointer to an integer. And you can see that in our constructor, we're allocating a new integer and storing some value in that location for our integer that we created. Now remember, the copy constructor does a member-wise copy. Our data member is our value address here. So it copies the address from object 1 into object 2, which basically means that it's pointing to the exact same memory and location that's holding the 13. So now we have two objects, two classes, that are pointing to the same memory. That's also called a shallow copy. The same problem occurs with assignment. Here it's doing a member-wise assignment. We've constructed object 1, and now we're assigning object 1 to object 2, which makes that member-wise copy. And again, we have that same problem where our objects are pointing to the exact same value. If we write our own copy constructor and our own assignment operator, instead of copying the address, what we can do is make sure that value allocates space to hold that value, and then copy in the value that was passed in by that object. So instead of pointing to the same place, we have made a new copy of that integer that our value is pointing to. And so that's what this is going to look like. And so if we've defined our own assignment operator here and did that new inside that assignment operator, instead of pointing to the same memory location in both objects, we've created a new memory location for the second object, and now when we set that to 13, we are not impacting the original object because our pointers are not pointing to the same place. Now when we created our copy constructor, we created it as a constant reference because we had mentioned that we didn't want to make a copy to create a copy. And when you pass something by value, meaning if you don't have that ampersand on there, it tries to make a copy. Well, we just learned how a copy is made. It's made by calling the copy constructor. So if you try to pass your parameter by value, you would be calling the copy constructor, which would then be trying to pass by value and call the copy constructor, and you're going to end up in an infinite loop. Then we also want to put const on here. Since we can't pass it by value, we want to make sure we're passing it as a constant so that we can't make changes to the parameter when we pass it in to make a copy of it.